135 million people currently inhabit the Sahel belt, a vast expanse where the struggle for survival is tied directly to the health of the soil. Life here is quietly but steadily retreating as the environment transforms into an inhospitable wasteland. Tens of thousands of hectares of fertile land vanish every single year, consumed by the relentless process of desertification. Why would releasing tortoises into these barren reaches be the proposed solution for such a massive ecological crisis? The answer lies in the unique biological role these reptiles play within a collapsing ecosystem. To the north, the Sahara operates as a massive engine of aridity, draining every fraction of moisture from the atmosphere. Young plants often wither and perish before their root systems can penetrate the hardened earth. This leaves every restoration effort hanging by a fragile thread, as the heat and lack of water negate human intervention. But this is just the beginning. The Sahara covers more than 360 million hectares of the African continent. This territory is larger than the entire United States, yet it functions not as a simple desert, but as a complex and extreme climatic system. One can notice how the shifting sands move in massive waves, driven by winds that strip the nutrients from the surrounding regions. It only looks obvious that planting trees would be the primary defense against the encroaching dunes. In reality, the survival of those trees depends on the hidden work of local fauna. The process is only gaining momentum. Scientists are now focused on the specific mechanics of how tortoises interact with the parched soil. These slow-moving creatures act as natural engineers, burying seeds and fertilizing the ground through their migration patterns. The camera glides along the cracked earth, where these reptiles navigate the harsh terrain. Their presence ensures that seeds are distributed in a way that manual labor cannot replicate. The equipment used to monitor these desert zones reveals a grim reality of soil degradation. Because the tortoises are adapted to extreme heat, they can survive where other species fail, maintaining the biological cycle of the land. Everything only gets more complicated as the desert expands further south. A single tortoise can travel significant distances, carrying the potential for new growth within its digestive system. It is visible how the hard shells of these animals protect them while they perform the vital task of seed dispersal across hundreds of hectares. This strategy represents a fundamental shift in how humanity approaches land restoration. The material and biological balance of the Sahel depends on these small, calculated interventions. From here, the transformation of the desert moves into a phase where biology and climate science must work in perfect synchronization. Thus ends one of the primary observations of the initial restoration phase. 40 degrees Celsius is the temperature the ground surface often exceeds during the day, baking the soil until it is completely parched. Why does such a persistent thermal cycle destroy the earth? It would seem that heat alone is the primary adversary. But in reality, the rapid cooling of the air at night creates a violent contraction that fractures the soil structure from within. In many regions of the Sahara, this cycle has operated continuously for thousands of years without the presence of rainfall. Decades may pass without a single drop of water touching the ground, leaving the landscape in a state of permanent exhaustion. Evaporation rates reach up to 236 inches per year in this environment. This is just the beginning. The heat does not merely burn the surface, it actively drains every trace of moisture from the atmosphere. Even if rare rains occur, the parched earth cannot absorb the liquid before it vanishes back into the air. One can notice how hot winds and sandstorms sweep across the vast landscape, carrying fine dust to the edges of the desert. This movement suffocates young seedlings at the precise moment they begin to emerge, preventing any natural recovery of the vegetation. The Sahel exists as a fragile frontier of life between the arid Sahara and the tropical south. It only looks obvious that a semi-arid belt could support life, but in reality, it carries the livelihoods of more than 135 million people. These populations depend directly on small-scale farming and livestock herding for their survival. Because the environment is so unstable, even minor changes in water conditions escalate into a crisis. The limited rainfall is never enough to compensate for what nature quietly takes away during prolonged dry seasons. Hot winds and erosion strip away the topsoil until a hardened surface as solid as stone is exposed. It is visible how the soil structure degrades until rainwater can no longer infiltrate the deeper layers. Plant roots fail to anchor in the compressed earth, and the ecosystem's ability to recover gradually disappears. This degradation does not unfold dramatically, but reveals itself through the smallest signs. Shrubs grow ever sparser, and grasslands shrink under the relentless pressure of the climate. Herds are forced to travel farther in search of water, and once cultivated fields are abandoned to dust and silence. Everything only gets more complicated as the Sahel loses its ability to regenerate. Scientific attention has recently turned toward a native species known as the Sulcata tortoise, or the African spurred tortoise. This species was once widespread across the entire region, but its population has declined sharply due to livestock grazing and habitat loss. Currently, the tortoise is present in only about 16% of its original range. As the tortoises disappeared, the critical ecological roles they fulfilled vanished, causing land degradation to accelerate. At first glance, the idea of reintroducing tortoises seems implausible. How could such a slow-moving animal make a difference in a harsh desert environment? The answer lies in their evolution over millions of years, which has perfectly adapted them to arid conditions. This unique biological resilience led to the selection of Sulcata tortoises for conservation programs, specifically in Senegal. Since the mid-2000s, international and local organizations have carried out reintroduction efforts in the region. The equipment gradually monitors the high survival rates and clear signs of natural reintegration within these protected areas. These initiatives are not yet considered a large-scale solution to the problem of desertification. However, the successful return of the species has opened up a new perspective on biological restoration. The process concludes this phase, opening the road to a more complex understanding of desert ecology. 8,000 kilometers. This is the total distance across the African continent intended for the realization of the Great Green Wall. Why was such a massive engineering and biological undertaking launched by the African Union in 2007? A project of this scale was designed to counteract land degradation along the entire Sahelian belt, beginning in Senegal. But in reality, the first path humanity chose was not always aligned with native biological solutions. Long before ecological restoration through local species was taken seriously, the Sahel had been placed into this far bigger and more ambitious gamble. The process is only gaining momentum. One can notice how the Sulcata tortoise utilizes powerful forelimbs shaped like natural shovels to penetrate the earth. What truly captured researchers' attention was not the speed or strength of this reptile, but a specific behavior that has defined the species for millions of years. Digging serves as the primary mechanism for survival and environmental transformation. These tortoises can excavate deep shelter burrows measuring several meters in length, with some tunnels reaching depths of 3 to 9 meters below the surface. At first glance, these are merely underground shelters, but in reality, they serve as vital infrastructure for arid ecosystems. In the Sahel, the ground is often baked so hard by the sun that it forms a crust with the density of concrete. This impermeable layer prevents rainwater from penetrating the substrate and allows fertile topsoil to be swept away by the wind. However, the structure is broken apart when tortoises begin to dig. Soil is turned over and loosened by the animals, creating openings that humans could only replicate with the use of heavy machinery. It gets more complex further on. Each individual tortoise burrow functions as a breathing chamber for the land, allowing rainwater to infiltrate deeper into the soil profile and improving air circulation underground. One can notice how on the surface, footprints and digging marks create countless microdepressions. These small indentations trap wind-blown seeds and retain moisture that would otherwise evaporate. This process unfolds slowly, but with persistent mechanical force. Each tortoise functions as a natural plow within its territory. When many individuals coexist in a single area, these small physical impacts link together to gradually improve entire stretches of land. Scientists describe this phenomenon as redesigning ecosystems from the soil up. It is visible how the restoration of a native species leads to the gradual restoration of ecological functions that were once broken. Everything only gets more complicated as these natural systems attempt to integrate with large-scale human interventions. From here, the transformation moves to the next phase of processing as the biological and mechanical efforts to stabilize the Sahel continue. 8,000 kilometers. That is the staggering distance across the African continent from Senegal in the west to Djibouti in the east. Why was such a massive scale chosen for the Great Green Wall? At first, the vision seemed simple, but in reality, constructing a continuous barrier of trees to halt the southward expansion of the Sahara proved far more complex than a simple blueprint. 100 million hectares of degraded land were targeted for restoration to provide sustainable livelihoods for millions of inhabitants. But this is just the beginning. Erratic climates and scarce rainfall quickly demonstrated that the Sahel does not obey human maps. One can notice how young trees frequently die before taking root, unable to withstand the relentless sandstorms and lack of water. By the end of 2023, international reports confirmed that only 15 to 20% of the overall goals had been achieved. In many regions, the absence of long-term care led to total failure. Local communities were sometimes forced to uproot the remaining saplings for firewood as a desperate means of survival. The process is only gaining momentum. Humans cannot impose their will upon the desert with rigid structures. The Sahel requires solutions that adapt to the land rather than fighting against it. If the Great Green Wall attempted to redraw boundaries on a map, the Sulcata tortoise reshapes the landscape in a fundamentally different way. Step by slow step, these animals work beneath the surface of the earth. Everything only gets more complicated. Ecological anchor points begin to emerge in areas frequently visited by the tortoises. One can notice how vegetation regenerates first in these specific patches, stabilizing the parched soil with roots. Insects arrive next, followed by small herbivores and eventually lower-level predators. This chain of biological recovery occurs with an orderly and clear progression. Transition to the next level. Scientists describe this phenomenon as clustered restoration. It only looks obvious to plant trees in a line, but in reality, these scattered pockets of life determine the entire ecosystem's endurance. Sulcata tortoises do not turn the desert green overnight. Instead, they perform the quiet task of preventing total collapse so natural processes can move forward. It gets more complex further on. The Ferlo Biosphere Reserve in northern Senegal has hosted a continuous reintroduction program since 2006. According to official conservation reports, approximately 80% of the reintroduced tortoises have survived in the wild. Many individuals have even begun to reproduce, which is a rare outcome in such a harsh environment. These results allowed the model to expand into Mali, Niger, and Chad. One can notice how the tortoises are bred under controlled conditions and released in small batches to minimize risks. It does not end at this stage. Restoring even the smallest natural links generates a resilient and lasting impact on the Sahelian land. But tortoises were not the only species returned to these grasslands. Before them, the Scimitar-horned Oryx had completely vanished from the wild. For many centuries, these animals were perfectly adapted to heat and drought. But hunting rifles and the expansion of livestock grazing pushed them to the brink. By the end of the 20th century, the oryx existed only in captive breeding facilities and on paper lists. 2008 marked the beginning of a bold effort in Chad to return the oryx to its native soil. After years of intense preparation, the first 25 individuals were released into the wild in 2016. Then, something few dared to expect happened. Calves were born within the first year, representing the first natural reproduction in decades. The population grew steadily from that moment. By 2023, the number of individuals surpassed 600. In 2024, the status of the species was officially downgraded from extinct in the wild to endangered. This represents one of the rarest conservation comebacks in modern history. The return of the oryx also facilitates the physical restoration of the land. Their hooves create small water-holding depressions in the earth, and their dung adds vital organic matter to the soil. These modest impacts trigger the return of life across the semi-desert. But the Sahel still lacks one final piece. One can notice the need for a species fast enough to connect these scattered pockets of life. The North African ostrich, once striding across these landscapes, is the world's fastest running bird. It disappeared from the Sahel due to habitat degradation and hunting. It was not until 2016 that reintroduction efforts officially began in Chad and Niger. The birds were raised in semi-wild conditions and monitored closely before their release. Survival rates reached approximately 85%, proving the ostriches could cope with the environment. Their return brings subtle but critical changes to the ecosystem. As they forage, they disturb the hardened soil, leaving depressions that collect rainwater. They also disperse seeds through their droppings across vast distances. Like the tortoises and the oryx, the ostriches do not fight the desert. They simply help the Sahel function once again in the way nature intended. The material is ready to move to the next processing phase without haste. One single miracle or a series of linear forests drawn on a map will not be enough to save the Sahel from encroaching sands. Why would massive industrial projects imposed from the outside fail to transform this arid landscape? It only looks obvious to assume that human engineering can force life back into the dirt, but in reality, the survival of this region depends on a return to biological origins. If this land still holds a true chance of recovery, it will come from the specific creatures that once inhabited these plains for millennia. The process is only gaining momentum. Sulcata tortoises move across the parched earth with heavy, deliberate steps, eventually digging deep into the hardened soil to create subterranean burrows. One can notice how these excavations allow the earth to retain moisture and reawaken dormant life from the depths of the crust. The Scimitar-horned Oryx also plays a critical role as it reconnects ancient migration routes across hundreds of kilometers. It is visible how their movements bring native grasses back to the surface through seed dispersal and natural fertilization. North African ostriches travel through the dust, linking fragmented ecosystems together through their enduring and constant movements across the terrain. Every individual species creates only a small, localized impact on its immediate environment. But this is just the beginning. When these biological actions are placed in the correct environmental context, the individual impacts accumulate to restore the natural rhythm of the Sahel. Transition to the next level. The struggle against desertification is not a mechanical battle against nature, but a technical process of repairing ecological systems that have been broken over decades. It seems simple to assume that rapid intervention is the only solution, but in reality, saving an entire landscape requires more than just raw force. One can notice the dust slowly settling as the animals re-establish their presence. What is required instead is patience and the precise ability to observe the environment as nature gradually heals itself through these native cycles. The restoration of the ecosystem through these specific organisms provides a stable and autonomous path toward environmental recovery. The material and biological foundation for the future is laid as the animals continue their work. Thus, the transformation of the desert moves into a calmer stage of long-term regeneration. From here, the natural balance reaches a standard ready for the further stage of growth.